Okay, so as in the last video, we have discussed molality, right? Which was a concentration term, of course, related to the mass, which of course means would not be affected by the temperature. Since it is independent of temperature, we don't have volume in it, since volume is affected by the temperature. If we increase the temperature, the volume is increased. If we decrease the temperature, the volume is decreased. But here in the molality, as you can see the formula, number of moles of solute per unit mass of solvent is what we call the molality, right? So here we cannot find any volume, and volume is affected by the temperature. That's why molality is a concentration term which is of course not affected by the temperature. It is independent of temperature. So we have actually discussed about two concentration terms related to the mass, the weight by weight percentage. Initially the weight is of solute, that 2 in gram, and the weight of solution, that 2 in gram. The mass of solute in gram per unit mass of solution in gram into 100 percentage, since we are finding the percentage, right? Weight by weight percentage. Then we found molality. Molality is basically a term related to moles. So number of moles per unit mass of solvent, that too in kg, is what we call the molality. Molality is represented by a small m, and the unit for it is mole per unit kg, right? So mole here represents the mole of solute per unit kg, here represent the mass of solvent in kg. In today's video we are going to discuss the two remaining terms, of course, ppm and ppb. ppm is basically parts per million, right? And ppb is parts per billion. Okay, so here we are actually going to start first the ppm, which is parts per million. Parts per million. Okay, so ppm, let me highlight it. ppm. Okay, see now what ppm represents. Basically ppm represents the number of or the mass of solute, a mass of solute dissolved in 10 to the power 6 kg of solvent, right? So here as you can see, let me tell you again what it is. The mass of solute dissolved in 10 to the power 6 gram, or you know what, mass of solution. What it is? It is mass of solute per unit mass of solution. You can see here we did not find any here volume, since volume is related to the temperature. It would be affected by the temperature, but parts per million is a concentration term related to the mass, which means of course it would not be affected by the temperature. It is independent of temperature. Into 10 to the power 6, we know that. How do we say million? This is right, this 1 2 3 1 2 3, this is what we call the million, right? So in million we have 6 zeros. You can find here, right? 1 2 3 4 5 6, that's why 10 to the power 6. Okay, so mass of solute per unit mass of solution into 100 into 10 to the power 6, right? Now see, let's see an example. Okay, for example, if we have 3 ppm, what does it represent? Or 3 ppm of NaCl. NaCl in water. Now what does it represent basically? Let me tell you that. Now see, 3 ppm of NaCl in water. Now it represents 3 gram 3 gram 3 gram of solute dissolved in some gram of solution into 10 to the power 6. Now what does it represent? Basically 3 gram of solute is dissolved in 10 to the power 6 gram of solution. Let me write this here. 3 gram of solute, or we must write here NaCl, right, since we have taken an example of NaCl. So 3 gram of NaCl is dissolved in 10 to the power 6 gram of solution. Okay, so what have we found here? 3 gram of solute, which is NaCl of course, is dissolved in 10 to the power 6 gram of solution. This is very small concentration term. Very small concentration term, right? Concentration term. Why is this very small concentration term? You can find here by the help of this example. 3 gram of solute, only there would be 3 gram of solute, and that would be dissolved in 10 to the power 6 gram of solution. Now you can see 10 to the power 6 gram of solution would be is very higher amount, right? But 3 gram is very smaller. So 3 gram of solute would be dissolved in the 10 to the power 6 gram of solution, which means this would be of course diluted solution, right, in which the concentration of solute is smaller and the concentration of solvent is higher. Now let's discuss our last concentration term, which is related to the mass, of course, which is not affected by the temperature, means independent of temperature. Very small, very similar to ppm. This is ppb, which is parts per billion. Parts per billion. Now see what is billion. As I told you about million, in million we have 10 to the power 6, right? Billion is actually 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 10 to the power 9, right? 10 to the power 9. Million is 10 to the power 6. Billion is 10 to the power 9. Here we have 9 zeros in it, right? So this is what we call the billion. In million we have 6 zeros. In billion we have 9 zeros. Now see, if I write the formula here for parts per billion. Mass of solute upon mass of solution, mass of solute per unit mass of solution, into 10 to the power 9, into 10 to the power 9. The formula for finding the parts per billion, right? Formula. The formula for finding the parts per billion: mass of solute per unit mass of solution into 10 to the power 9, which actually represents billion. Now see, let's see an example again. 30 gram of urea, which is of course solute, right? Non-volatile solute. I'll tell you about volatile and non-volatile when we'll discuss about vapor pressure, right? So this is basically N2H4 CO2, CO only, right? Because NH2 CO NH2 is the formula for urea. So NH2H4 N2H4 CO2 CO only, right, is dissolved in water. Now see how. 30 gram of urea would be dissolved in 10 to the power 9 gram of solution. Now you can see these both concentration terms which are related to the mass, they are not affected by volume, which means independent of volume. So they are very small concentration term, very smaller concentration term. We have weight by weight percentage, molality, parts per million and parts per billion. So in today's video we have actually completed the concentration terms which are of course related to the volume or mass. In the next video we'll start discussing about vapor pressure, and then we'll of course move towards the nature of the liquid, nature of the substance, which is volatile and non-volatile. Then we're going to discuss about Raoult's law, the combination of volatile, non-volatile, and volatile, of course. And then we'll discuss lowering vapor pressure, elevation in the boiling point, depression and freezing point. We're going to discuss each and everything in very detail.